Hey, what's up guys? So you've got your ultimate Arduino prototype board and now you need to build it. So you could use the design specification document, or you can watch this video and build the board with me in real time. So even if you're a little bit more experienced and you know what you're doing just by seeing a list of components and a board with the reference designators, that's okay. But in this video, I'm actually going to explain as I go what each component does, if it's needed, and why I selected that component. And there's a few tips and tricks I'll talk about while I'm building the board. Okay, so this is an Alpha 2 board, so not everything's perfect. So there's a few little things we need to do to make it all come together more easily. So get your soldering irons heated up and join me over here for the build. Okay, so just before we get started, I want to show you what a completed prototype board looks like. So right here is everything you will receive in the kit except for this resistor and this LED. Okay, I just soldered those on to test the board out. And the design specification document goes into pretty good detail on the entire board's functionality. And make sure you read that document before even starting the build. Okay, there's a lot of useful information in there that you need to know before building the board. Okay, so here is what a kit looks like when you get it. You have two cells within the package, one for the bare board and the ATMEGA 328 and all the components that go on the board. Okay? And here is a kit with all the components out of the bag. And the first thing you should do here after you read the design specification is count the parts and make sure you have everything that's supposed to be in the kit. Now, there is one part that is already soldered to the board, and I did that on my end here because I kind of goofed up and ordered the wrong crystal. I actually ordered a surface mount crystal, so I had to carefully bend the leads out and solder that to the board directly. And the reason I did it here was because it's very easy to accidentally bend the leads too far on the crystal and they'll snap right off. So I did that here for you already, so don't forget to count that component as well. Okay, so I think with the bare board there's I think there's 30 components, but double check that according to the design specification. Okay, so we're ready to dig in here. And obviously before you start you should make sure you have a clean workspace. This is going to be a little difficult for me to do just because I'm trying to also film the build here, so I'm kind of like at a weird angle. But make sure you have a clean workspace, open air, kind of good circulation, because there is going to be a lot of solder fumes. In fact, if you have some kind of fan in the room, that'd be a good idea so you're not just hovering over solder smoke, just blowing into your face. So anyway, let's talk about the tools you will need. Obviously, you will need solder. I have recommended solder in the design specification, but really any solder will do. Just don't use like plumbing solder. Okay, solder, wire cutters. You don't need needle nose pliers or long nose pliers, but it makes the job a little easier in certain parts when you need to bend leads. And if you screw anything up, desoldering braid or solder wick helps a lot to wick solder away. And let's see, obviously you will need a soldering iron, something with a fine tip. And make sure your tip is clean and not real jagged and dirty. Okay, so let's get started here. I haven't rehearsed this at all, so this is going to be a one-take video. Now, a lot of guys have different ways of approaching a board like this. Maybe they'll start with all the small components first and work their way up to the heavy, big components. For me, I don't really care. I'll just start with whatever component I pick up first. So the first component I'm going to pick up here is the switch. Okay, and it is S1 here, so that'll go right in. And if you have like what they call helping hands with like it's like a big thing with alligator clips that you can hold stuff while you're soldering it. That would help because like in a case like this, as I turn the board over to solder that component, it's going to fall back through. So let me show you a couple little tips here on how to do that. So right now, since it's the first component though, it's not too bad. I can kind of smash the board down against it to keep it right up there. But we will run into that issue where the component will want to fall through. So I'm going to go ahead and solder that on. Okay. Let's get that on there real quick. Okay. Switch is soldered and it works. Well, we don't know it works yet until we have the whole board put together, but at least it toggles. So inspect the solder joints, make sure there's no bridging anywhere, and not too bad. Actually, that one solder joint, it's kind of hard for me to see while I'm filming this, looking through the camera. Okay, that one could use a little bit more solder. Okay, so we're good. So one component down. Let's go ahead and do the, and the switch, by the way, controls power. So I'll talk through this a little bit. The switch controls the power coming from either the USB jack, which goes over here, or the barrel jack. Okay, so when power is applied by either the barrel jack or the USB jack, it will turn that power on and off to the entire board, including the Arduino. Okay, if you have a programmer connected to the board, either the Arduino programmer or the AVR programmer, it will not control that power. That power will always be to the chip and the board. Okay, and I get into a lot of detail with power control in the design specification. So let's go ahead and solder, while I'm holding this part, the USB jack. Okay, so I'm still able on this part to kind of perfectly balance it here so all of the leads stick through the board. And you know, when you're soldering these kind of parts on, make sure they're sitting flat on the board. You know, if after the fact you solder a part and it's kind of like sitting there like at a weird angle, like it's not perfectly flat, make sure you fix that. Okay, and you can fix that by kind of heating up all the leads and applying pressure to it. Alright, so just dump a whole bunch of solder into the two mounting pegs of the USB connector. And then there's 4 pins for this. 2 are for data, which we don't use. Okay, this is not a USB jack for programming. This is a USB jack for power only. But, and I included this just because USB power is so convenient. And one nice thing about it, though, is the 2 data lines, D plus and D minus, are broken out to through holes here. So if you want to implement some kind of virtual USB or like a bit banged version of USB 1.0, you can access D plus and D minus and do something with USB. So you can make your Arduino mimic like a peripheral device, like a keyboard or a mouse. And D plus and D minus allow you to do that. Okay. At this point, though, I have not proved that out, though, to test that at all. So that's on my long list of projects to do, though. Okay, so now let's grab another component here. And I'm going to do, there are a few components that we need to solder in order. And particularly the voltage control for the other voltage, or what I call the other voltage, which in this design is for 3.3 volts. So you'll read in the design specification that, you know, 5 volts and ground is bust throughout the entire board, but there's also this other voltage that's also bust. It's bust on the bottom and top of the board here. And usually this would be like 3.3 volts to control things like Bluetooth modules, a Wi-Fi module, XB radios, you know, anything that needs 3.3 volts. And we do this by using a linear voltage regulator, and this is an LM317, and I've made it adjustable so you can kind of fine-tune it to get perfectly at 3.3 volts. Well, the only problem here with the Alpha 2 board is that this potentiometer here is a lot bigger than the footprint that I used on the board. So if we did populate this, it covers up R5 and R6. So you need to make sure that you solder R5 and R6 before you solder the potentiometer. Okay, so let's just go ahead and do that right now. So here's R5 and R6, which are 1 k ohm resistors. So the color code is brown, black, red, gold. Okay, so they're 5% quarter watt resistors. And this sets up the biasing for the LM317. Okay, we're going to go ahead and stick those through. You know, sometimes people will go ahead and stick all the parts through the board and then solder everything, so you have like all the leads sticking out of the board, and then they'll go through and solder everything and then cut it out. I find it a little bit easier and more organized to just do one or two components at a time. So in this case, since these are kind of a grouped set, we'll do these both together. So R5 and R6, let's get those in there. Okay, Lum. And by the way, I'll talk a little bit more about this circuit here, the LM317 circuit, in a future video, so that you can change it and do whatever you want with it. You don't have to use it for 3.3 volts. Okay, so I have R5 and R6, so let's go ahead and solder those in. Okay. That's not the prettiest solder joint. Okay. Okay, now these leads are a little bit longer than the switch leads and the USB leads, so you'll actually have to trim these down, which is a nice thing with these side cutters. You can get really close to the board. Don't get too close to the board where you're cutting solder. Just get down far enough where you're just cutting the lead off. Okay? It's not too bad. Oops. And save these leads because they're going to come in handy later. And I'll talk more about that later on. But anyway, let's continue on. So we've got R5 and R6, and they turned out pretty good. Now we could solder the potentiometer on, and it solders right in there. It fits, the leads fit perfectly, but the footprint does not. So it's going to be a little elevated off of the board, which shouldn't be a big deal. Okay, so get it on there, and it's going to be colliding with R5 and R6. And this is a perfect example of a component that's big and doesn't really sit flush. So I'm just going to go ahead and bend a couple of the leads here so that it stays in place while I'm soldering it. Okay. Okay, almost done. And when you're soldering, make sure that the soldering iron is touching both the pad on the board, the pad and the lead, so you're applying heat to both the lead and the pad, and the solder will wick right into the joint. Okay, so we got R5 and R6 done, and R1, which is the potentiometer. I have the design spec here open while I'm soldering it, just making sure that I'm doing this in order. And this potentiometer, by the way, is a 10K ohm potentiometer. Okay, so now I'm going to do the LM317. Just stick it right through. Now this is a polarity sensitive component, or an orientation sensitive component. Okay, so you can see that the white bar here along the side of the component, that's where the tab should go. Okay, don't put it in this way. Make sure that the tab lines up with that white bar on the silk screen, okay? And when you're holding it like this, with the tab down, the pin all the way to the left is pin 1, and that is marked on the board with a little white dot, okay? So I'm gonna stick this in, and this is another component that you need to bend the leads a little bit just to kind of hold it in place while you're soldering, okay? All right, let's get that real quick. And you can kind of see my soldering technique where I'm applying heat to both the pad and the lead at the same time. Okay. And we'll trim the leads away. Okay. Okay, pretty good. We're getting there. All right, so that's the other voltage regulator circuit. It's just those few components. Well, actually, there's one more. In fact, I guess, let's do this header while I've got it. So this is the 6-pin right angle male connector, and this is 0.1 inch spaced, or 2.54 millimeters. And this mates with the ultimate programmer board. So this would solder on right there, and it plugs in just like that. Okay. So it has this little plastic standoff here. Make sure that part is the part that plugs into the board. Okay, don't plug it in like this, because then there's not enough meat on the header for the programmer to plug into. Okay, so the long ways here, or the part of the header that has the most meat, should be facing out. Okay, so this is one where the leads barely stick through, and there's no way to bend them. They're too thick, so it's kind of hard to solder this. So, and I can't jam it with anything here, like against the table, because there's other bigger or taller components standing off the board. So there's a couple ways you can do this. You could find something to jam under there. Like even this styrofoam might work. I can sort of jam it and then solder it like this. Or a little kind of quick and dirty way of doing this is to kind of goop on some solder onto your iron until you have like a little bubble, not too much, and just let that chill. And then I'm going to, it'd be kind of funny if I burned myself while doing this. And then you kind of line up the header on here. Actually, that wouldn't be funny. And then you line the header up like this, and I've got a little ball of solder here, and I'm just going to kind of smear it on one of the pins, just barely. And it's not a permanent solder joint. It's just to hold it in place. So see, now that header is perfectly placed exactly where I want it. And I'm going to clean my tip off. I've got a brass sponge and an actual sponge. And now I can go ahead and solder the rest of the pins. Don't resolder that one because the header will just fall right out. But I'm going to solder the other 5 pins real quick. And then I'll clean up that pin here. And we're done. Okay, so that's a nice little trick. And it's soldered perfectly. And you want to make sure that that plastic part of the header is fully seated onto the board. You don't want it too crooked either. Okay, so let's do this, the DC power jack here. This is the barrel jack. I believe it's, this is a 2.1 millimeter barrel jack, meaning that the center pin has a diameter of 2.1 millimeters, and it's center positive. And unlike the Arduino, this is a big difference from the Arduino. This barrel jack only accepts 5 volts. Okay, on the Arduino, it has a voltage regulator to bring anything down on the barrel jack down to 5 volts. In this case, you need to only apply 5 volts to the barrel jack. Okay. Okay, let's bring this in, and we're gonna have the same problem here. The leads are not long enough to bend. You might be able to do it with this. So I'm going to have to get a ball of solder onto the soldering iron here. Okay. So I got a little bit of a ball of solder on there, and then I'm going to kind of smear it onto one of the pins, and now it's holding it up perfectly, exactly where I want it. That's a little crooked, but that's good enough. Okay, and these holes, or these pads, are really big, so you can just kind of fill them with solder. You don't have to go crazy with it, just enough so you've got good contact. Okay, now the barrel jack is soldered. Okay, now I want to talk about something else which I forgot to mention. The 6-pin header here, all of the pins do have the pin out silkscreen on the board, so you know which pin is which. So ground, and then there's a blank, and then VCC, which is the 5 volts, RX, TX, and the DTR reset pin. If you look closely though, there's these through holes inside here, right? And what you need to do, and you'll read this in the design specification, is take extra leads. Let me cut the solder off of this one. Take some extra leads and bend them and make little mini jumpers and place those inside there. Just like that, vertically like this, into each one of those. And what this does is connects TX on the chip to TX on the header, okay, because they're separated out. And the reason for that is because I wanted to add, in certain cases, you might need to add impedance in between TX from the programmer and the microcontroller. But 9 times out of 10, or maybe 9.9 times out of 10, you will not be doing that. So just take leads and put them in between those two through holes and create just a little short. Okay, and make sure you read the design specification for a little bit more detail about that. So you don't want to go this way. Make sure you go this way. Okay, and if that doesn't make sense, make sure you read the design specification. And if you're still confused, send me an email. Okay. And I'll make it more clear in that design specification. Okay, and if, I'll have a few projects in the future where I actually need to add impedance in between there, or have, a little bit more control over the TX and RX being connected to the board. And I'll talk about that. So in those certain special cases when you need to do that, I'll have example projects in the future. And it's really about having, using your UART on your microcontroller on your Arduino, the TX and RX line. If you're going to use them as kind of a bus signal, so you have multiple devices all communicating on the same TX and RX line, that's the whole point of wanting to add impedance there. Okay, so anyway, let's keep going here. I'm getting sidetracked. All right, now let's talk about the diodes. Okay, there's some diodes in the circuit, and these serve a couple purposes, but most importantly, what they do is allow for reverse polarity protection, which is nice, or accidental use of having multiple voltage sources connected to the board at the same time. Okay, so like I'm talking about if you have your programmer plugged into the board and then all of a sudden you plug in the USB port, or you have, you have this programmer, the Arduino programmer, plugged in, and then you connect the USB jack. So it protects against all of these things. So if you plug in two sources of power into the board, it doesn't blow up any of your programmers and stuff. And I get into pretty crazy detail in the design specification about that. So let me go ahead and install these. I'm just going to cut these out of the tape here. Oops. Now I talk in the design specification that a major drawback with the diodes is that you're going to have a voltage drop. So, if you've got nice, clean, solid voltage on the barrel jack here, 5 volts, and it looks really nice, on your bus lines, the 5 volt and ground going throughout the board, you're actually going to have a drop there. You're going to have something, 4.4 volts, 4.3 volts, because you're going to have that forward drop of the diode, okay? And if that's not okay, all you have to do is put a bare wire across all of the diodes. So D1, D2, and D3, just put a bare wire there. So you lose the protection, but you don't have the voltage drop. And the voltage drop is not constant. It kind of changes with what kind of power consumption you have in your circuit. Okay, so diodes are polarity sensitive, or what I'm calling polarity sensitive. You need to put them in a certain way. So you'll see here there is a white line here showing the cathode. On the diode itself, there is a white line going around the diode. So make sure you put the diode in that way. If you don't put it in that way, it will not allow current to pass through, and you will not have any voltage on your board. So nothing bad would happen if you put the diode in backwards. It just wouldn't work. Okay, we'll pop all these guys in. Okay, D1, D2, D3. All right. These have a little bit bigger gauge leads on them, so it takes a little bit more heat to heat up the leads to allow the solder to wick into the joint. Okay, and the traces on the board that carry the power are a little wider than the rest of the traces, so that also makes it need so you need to apply more heat. All right, well anyway, okay, and then we can get into, you know, I do have thermal reliefs on those pads, and you know, once I break open the Eagle PCB layout and we look at all of the traces and how the board was laid out, we can talk about things like that. Okay, so anyway, let's keep going. I keep getting sidetracked here. So now let's do the capacitors here. I'm going to do the Arduino last, and the reason for that is because we're handling the board so much, and I want to be careful with static. Okay, so I don't want to cause any static on the Arduino and damage the pins. And you might have noticed I'm not wearing a static bracelet or anything, so I'm not grounded. And I probably should have talked about that earlier, but make sure that you are grounded. So, you know, before you pick up any component, you know, touch something that's solidly grounded. Okay. And most of these components aren't static sensitive except the Arduino itself. Okay. All right, well anyways, let's keep going here. I said the capacitors. So we're going to do the electrolytics first. And we have a 1 microfarad and a 10 microfarad capacitor. These are C1 and C2. C1 is the 10 microfarad capacitor, so we'll do that one first. And these are definitely polarity sensitive, so you want to make sure that you get these right. If you put these in backwards, bad things will happen. You could blow up the electrolytic capacitor. Okay? So C1, and if you look at there, it's kind of small, but there is a negative and a plus sign on the silk screen on the board, okay? On the capacitor, there's a big marking here showing the negative lead of the capacitor, and the shorter lead on the capacitor is the negative terminal, the negative lead. Okay, so let's line that up, put that in. So the negative on these, though, points to the left, just in case you can't read it on your board for whatever reason. But it is pretty clear, and it's marked nicely. Put those in. I'll just go ahead and solder this one real quick. Okay, tip's getting a little dirty. Let's clean that up. Okay, up next now, let's do C2. Now C2 is the 1 microfarad capacitor, and it's got bent leads out, okay? And it's in tape here, so you can't really tell, well, you can kind of tell which one's the negative lead, but you also have the marking on the capacitor here. But this one is going to go in kind of strange. So you can see the footprint I have there doesn't quite fit these leads. So you're going to have to bend the leads to fit it. Okay, and if I play with it a little bit, I can get it down there just right. And I want to get it seated all the way to the board. And make sure as you're pushing it through the board that the leads do not touch each other. You know, you don't want the negative and positive leads touching each other when you solder it to the board, because that would be a dead short from 5 volts to ground. Okay, those 2 caps are in. Okay, so up next we're going to solder on the 6-pin header. This is a 3x2 header used to program the ATMEGA 328, and you would use this to either program the Arduino bootloader, or if you want to take the next step from the Arduino and program it as an AVR. Okay, so using just, you know, a regular C compiler and putting your code together, so not using the Arduino IDE. Okay, so but anyway, let's solder this guy in. And by the way, when I cut these out, I cut them out of a 40x2 header, so these pins may be a little messed up because when I cut them, it kind of shook some of the pins loose. So in case you have a header with loose pins, I apologize for that, but it shouldn't be that big of a deal to kind of reline them up and solder them to the board. Okay, so again, this is going to be one of those parts where we have to goop some solder onto the iron tip. We'll go ahead and do that. Get a little bit of solder on there. Flip it around. And you know, one thing you should watch out for is when you're doing this, make sure you're not touching the pin that you're going to smear the solder onto. Okay, I think I got it. Nope, not quite. Let's try it again. This one's a little bit more tricky. Still. There we go. Had to let it dry. Okay, now I'm going to clean my tip off a little bit. Okay, that's better. And where's the part? Right here. And let's go ahead and solder this guy in. Okay, clean up that joint. Make sure there's no bridges. Everything looks good. All right, good. And we're done with that component. All right, now let's do the 2 10K ohm resistors. And these are brown, black, orange, gold. Okay, 10K ohm resistor. And we'll pull these out of the tape. And these are R3 and R4. Okay, and these are used to pull up the reset pin on the Arduino or the ATMEGA 328. And the other one is to help the programming of it. See, this is a good example of where the long nose come in handy, where you can kind of pull the leads through and get a nice seating of the component. Okay, so I got R3 in. Make sure you bend these close to the body of the component. That would help a little bit. Get R4 in there. I think on the next version of this board, I'll make the footprints a little wider so the leads go in a little bit easier. And you know, anything that you run into while you're building the board, just let me know, because I'm looking for that feedback, since all of you guys building the board are my alpha testers. Okay, let's get these all soldered in. Those look good. Let's snip the leads away. We'll get these out of here. You know, when you snip these leads away, and if you're working on carpet like I am here, try not to drop these, because you will never find them in the carpet, and when you step on them, well, that's when you'll find them. Okay. Oh, and by the way, so over here, this is the LM317 that we soldered earlier. I left a little extra space in between here, so in case you are pulling a lot of juice off of the 3.3 volt supply or whatever supply you set up here, you've got enough room in there that you can put a heat sink. Okay, and I'm not expecting you to pull a lot of power out of this supply, but if you are, it will help get rid of some of that heat off of the tab.
but you probably don't want to be pulling a ton of power because that heat will radiate into these electrolytic capacitors, and that could be bad news. Okay, so we're getting there. So now we have 4.1 microfarad capacitors, and you got to be careful here because there's actually 6 capacitors that all look identical. Okay, but if you look at them carefully, there is a 104 on the 0.1 microfarad capacitors, and there is I believe a 150 on the 15 picofarad capacitors. Okay, and the way you read these is so it's how many zeros away from picofarad you are. So when you read 150, that means you're 15 with 0 zeros away from picofarads. So you're at 15 picofarads. I don't know if that's a good way of explaining it. 104 means that you're 10 plus 4 zeros away from picofarads. So 3 zeros puts you at nano. So you're at 10. Wait, do I have that right? I'm just looking here, making sure that I stated the right capacitor value. Right. So you're 4 zeros plus it's 10. So you're actually 5 zeros away from picofarads. So there's 3 and then another one, and then you're at 10. So you're actually at 100 nanofarads or 0.1 microfarads. Okay. Anyway, 0.1 microfarads. Capacitors are C3, C4, C7, and C8. Okay, so let's just go ahead and do those. C3. And these are kind of like the, I believe it was C2, where the leads kind of bow out right off of the body. But if you can kind of finagle with them a little bit, you can get the body pretty close to the board. And this is another thing that I think I'll fix on future boards. You're not going to be able to get the capacitor seated all the way to the board, but you can get it pretty close. And in this case, as you push the capacitor down to the board, the leads kind of start smashing against each other, almost to the point where they're touching. So you want to be careful and make sure that they're not touching. All right, I think we could go ahead and place a lot of these. Then there's C7 over here for the analog power. Okay, that one was a good one. I got that one in. Okay, we've got C8, which is the capacitor for the other voltage, or the 3.3 volts. And these are, these are decoupling capacitors. Okay, they just stabilize your line. Make sure that you don't have any noise on the voltage there, your voltage supply. This one's being a little trickier to get through there. Okay, that's good enough. Got it here. Now this one over close to the potentiometer, when you're soldering the leads, you're kind of close to the body of that potentiometer, which is made out of plastic. So make sure that the metal lead is not touching that plastic body. All right, because it'll melt. And we have one more here. This is the two 150s. And we have one more which goes up here, C4. Okay. We'll get that on. Straighten it up a little bit. Okay, that's good. And let's solder. Go ahead and solder all those on. So since these are just decoupling capacitors, the board will work without them. But the microcontroller is a very noisy device. So if you have any sensitive communication going on, or any other devices connected to this, you may get some odd behavior. Like your analog readings may be kind of, because there's just so much noise on the voltage rails, that you may get some weird readings off of the analog inputs. Things like that.
Okay. And that's the same thing with the big electrolytic capacitors. These are C1 and C2. Those are your bulk storage capacitors, and they really just try to maintain that your voltage, your 5-volt supply going throughout the board. And since this whole area, you don't have any decoupling cabs out here, it's a good idea that if you do put any devices out here that use that, you should always add in a 0.1 microfarad capacitor. Just sprinkle it and get it as close to the supply line for that device as possible. Okay, so up next is the two 15 picofarad capacitors, and these are for the crystal circuit going to the Arduino. And maybe I should have done this earlier because it is kind of a tight squeeze in there. I'll get those guys in there. That's not too bad. Make sure that the leads are not touching each other. They're not touching other components. Okay, we'll solder that in. Okay. Good. Okay, so we're almost there. Now we can solder. Let's go ahead and solder the 20 pin and the 28 pin. And this was, I was looking, there's 28 through holes here that are broken out for the Arduino pins and the supply pins down here, so ground, 5 volts, and the other voltage. I was looking for a 28 pin header that would just go straight across, but the best I could find was a 20 pin and an 8 pin. And you would think that if you butted them up next to each other, the spacing between the two headers would be the same as the distance between each of the pins. So that's not the case though, because when you go to put these in, you'll notice that the 8 pin doesn't really fit. So to get this to work, you kind of have to angle the two like this. Let's see if we can get a better shot of that. So you kind of angle them like this, and they just barely don't fit. So you can kind of smash them in. And if you really struggle with this, you can cut a pin off of the 8 pin header here, and then you would lose maybe one of your grounds or something. But anyway, if you do it like this, and you kind of smash it, you can get the two in there just fine. Okay, there we go. And it's such a tight fit that you don't have to goop the solder onto any of the pins on the back side. All right, and this is a good example of why you would want a fan running, because this is going to generate a lot of smoke here as I go down the line here. Okay, so now you have the headers soldered on, and these are not necessary by the design, but they are nice to have to prototype with. So I'm looking for a little wire. I could show you an example of that. So if you have little jumper wires and you have your breadboard out here, you can use this just like the headers on the Arduino to plug your jumper wires to, and then you can build your whole circuit up here on a breadboard, and then when you want to take it off the breadboard, you can slowly take the components and put them into the permanent prototyping area. And it just makes the whole process a little easier. Okay, so now we're ready for the Arduino. So we'll start with the socket here. We'll drop that in. And the socket, and the Arduino is obviously orientation sensitive. Okay, and that's a term I keep using, but so the tab in the chip here, there's a little tab at the top of the chip, should line up with the tab up here, the dimple in the chip. And the socket also has that. And if you don't want to use the socket, you don't have to. You could drop the chip right in. But then if you smoke that chip or blow it up or whatever, which does happen, you can change it out if you use a socket. So let's get the socket in there. And I am going to use the socket because I've blown these up
a million times. Okay. Now the pins might be a little bent, you know, as they move through shipping. So just bend them out straight, get them in there. And for this, we could use the goop technique where you goop one of the leads in the back to hold it in. Or these leads stick through enough that you can kind of bend them. Just don't stab yourself when you're doing this. Okay. Yeah, let's make some smoke. Okay, so that's soldered in. And this is one of those things that's really easy to get a bridge between the two pins because you're kind of going quickly soldering. So make sure that you don't have any solder bridges between two pins. And if you do, you can, with this kind of thing, you can easily kind of wick it away. But if you can't and you're kind of new to soldering, then you can use the solder wick where you, actually, you know what I should probably do is just, let me create one and show you how this works. So I'm going to create a solder bridge here. If I can. It's kind of funny if there's one. Probably the one time I want to create a solder bridge on purpose, it wouldn't let me. So anyway, with the way the solder wick works, I'm going to cut that off. Is you just simply hold it to where you want and then lay the soldering iron right above it and rub it. And you'll see the braid start to suck up solder and it kind of gets shiny. And you see, it did fix that bridge. You might not be able to see it on the camera there, and then when we're done, we cut that away. Okay. I just wanted to show you how that works. Another thing I was just noticing while building this is this solder has a lot of flux in it, so you can see all these like wet spots on the board. There is like actual stuff you can buy that'll help remove that. It's like Flux Off or something like that. But if you just want to get most of the big stuff off, you can use rubbing alcohol. I haven't tested it out yet, but that's just what I've heard. So, if it really bothers you, you can try that. But you won't really see that unless you're looking at the bottom of the board. Okay? And, another note on safety, I talked about not breathing the solder smoke in, having a well-ventilated room, or maybe even a fan running, is this solder here is leaded solder. So I'm handling it a lot, but before I go eat something or do whatever else, I'm going to make sure I wash my hands. So do the same. You don't want to be eating lead. Okay, so now we're going to put the ATMEGA 328 chip inside the socket, and the reason I'm talking about this is because it's important. If you look in the socket here, the pins should be seated right in the hole of each of the pin sockets. So, and I'm pointing this out because it's very easy for the pin to kind of stick right in between where it's supposed to go and the little metal leg that sticks up, and you won't have good connection of the pin on the chip to the socket. So what you need to do, and also because this is kind of sticking like this and you want it to be straight in, so you actually need to sometimes take the chip and make sure you're grounded right now too, obviously, because you don't want to have a electrostatic discharge into the chip and damage anything. So I'm kind of carefully holding the chip here and straightening the pins out so it goes into the socket a little easier. Okay, and that's pretty good. So instead of it being like that, now it's straighter, and it's almost like this, the pins. Okay, let me see if I can get that on camera, and you can kind of see what that looks like. So now I can get it in there, and I'm gonna line up the pins and make sure that they're all seated right into where they're supposed to go in the socket, and not like right outside the socket smashed between the plastic. All right, I got it in there, and then I'm going to evenly, on both sides, push in. And then I'm going to give it another look here and make sure it's in. Okay, and that looks pretty good. Okay, so now let's talk about these analog pads over here. Now, I've given you these pads so that you have a little bit more flexibility with your analog design. So you could do a lot of creative things over here. This chip has a ton of functionality, you know, way outside of anything you've seen within the Arduino IDE. You can do a lot with the analog section. So I've given you these pads here so that you can fully disconnect from A ground, A ref, and AVCC. So right now they're fully disconnected. We have through holes here so you can run wires over to here for A ground, A ref, and AVCC. So if you want to, you know, make your analog reference something crazy, or your analog VCC something, or your A ground, you know, anything you want to do, you can do. But if you want to set it up just the way the Arduino is, then you need to dump solder on these pads to short the two pads there on A ground. Okay, there we go. And AVCC. Okay. You just kind of melt solder and create a bubble right on top of those two pads so that they short together on A ground and AVCC. And now the board will function and act just like an Arduino. And in a future project, I'll give you a few examples of things you can do that, you know, that exploit breaking out these pins. Okay, so I think that's it, actually. To test the boards, you're going to need a multimeter, okay? Well, to test the boards properly, you could just try to be lucky and plug the boards in, but you could blow out your USB port if it's not protected. So good idea to make sure you don't have any shorts. So we'll set it to continuity meter so it beeps when we have a short, and we'll check for shorts from the 5-volt supply to ground, and the 5-volt bus is going through the entire board. So test from 5-volt to ground, test from ground to other voltage as well, and we have the two other volt rails here going along the top and bottom. But since there's diodes in series with the power input, you need to also check for shorts on the anode side of each of those diodes. There's 3 diodes to ground, okay? So I'm going to put one lead to ground and then check the anode. And make sure the power switch is on, although in this case it wouldn't matter. But you hear the beep, we have a short. And then anode on that. So we have one short, and that's on D1, and I could pull the schematic to see which one that is, or I could look at the input. So that's either a short on any of these pins, it's a short on any of the USB pins, or the header pins. Now I did solder these through the camera, and I did see this later on, but honestly, I didn't do this on purpose. So this was a real accident, and it's from 5 volts to ground on the USB connector. There's a little bridge there between the two pins, so I need to fix that. So it's kind of funny that this actually happened, but it's a real short that I didn't do on purpose. So I'm gonna just try to do it without the solder wick, and that's it. Okay. I was probably rambling through that part when I was doing that. All right, so let's try again now. Ground to 5 volts. I'm going to do all the tests again, make sure I didn't create any shorts, and check all the anodes. So now there was no beeping there. You can check on the cathode side as well, which the cathode side is all the 5 volts. So it's the same as doing this test. So that worked out good. Now the board can be plugged in. To test this, you just need a USB cable. So you can plug it right in to this. You can use a USB port that plugs into the wall if you want, or you can use your computer. If you use your computer, it's a little bit more risky if it's not protected. On my MacBook here, it is protected. So if I plug in and there's a short, it disables the USB ports. So if we plug this in, before we do that though, make sure that the board is clean. You make sure you don't have any leads stuck to it. You know, if you're a messy worker and you've got a lot of these leads that you cut off on your board and you turn it on while that's laying there, well, you know what's gonna happen. So let's get rid of that. Make sure everything's clean. I'm going to plug the board in. Okay. Plugged it in. It's plugged in. I do not see the anything pop up on the MacBook here, so that's a good sign. I got it set for voltage now, and I'm going to be very careful now to not short anything. and I'm going to put one lead on the ground, the other on 5 volts, and I see 4.75. So I see 4.75 volts, and then on the anode over here, I'm being even more careful, is 5.02. So you can see the voltage drop there from 5.02 to 4.76. Let me get the meter in frame there. 4.76 to 5.02. So there is a little bit of a drop there. If I didn't want that drop, if I wanted that 5.02 out here to be used by the Arduino, I would just put bare wire in for the diodes. Okay, so that's good. Now let's check the other voltage here. So I'm going to put one lead. Actually, I don't have to do it that way. I'll put one lead on ground and then another lead on other voltage just to see what's coming out. And we're getting 3.93. Okay, so this needs to be adjusted. I'm going to grab a little jeweler's screwdriver here. I think this should work. And we're going to adjust that voltage real quick because I actually am planning to use that voltage here on this board. So 3.93, and I'm just going to adjust it. And this isn't a perfect circuit. I'm going to work on this a little bit, make it better. Okay, so turning to the right increases. Let's bring it down. Okay, it's kind of sharp. I want to make this a little bit, have a little better dynamic range here. Okay, we're getting there. Oh, just past it. Yeah, it's a little too sensitive. I'm not crazy about that. Okay, we'll just get it right in there. I know this is exciting video to watch. I just keep passing. It's not perfect. So I may even at one point come in here and I'll revise the design specification with other resistors you could use for besides the 1K ohm resistors. Maybe I'll have to come back to this. And this is a linear voltage regulator. 3.5 is okay for now. Because since it's a linear voltage regulator, as I add a device out here to use the 3.3 volts, it doesn't have feedback. It's not a closed loop voltage regulator, so it will pull that down. Okay, so we have the 3.3 basically set up. Now I want to actually test to make sure the Arduino is working. Every board that is shipped has an Arduino bootloader programmed that actually turns on and off pin 13, okay? That's the default sketch that's loaded. So I have to go to pin 13. It's kind of hard to see. But the silk screen on the left here is everything that you would see on an Arduino board. The silk screening to the right here is the actual ports names for the ATMEGA 328. So if you pull the datasheet for an ATMEGA 328, this is what you would see on the right side. On the left side is the Arduino designations. So I kind of have to turn it this way so I can see which one's digital pin 13 and then ground. So I have an LED connected through a 1K ohm resistor there to test this out. I'll throw that on the other side. So it connects through a 1K ohm resistor to the anode, and then the cathode's connected to ground. So that's what's kind of cool about this board is you can prototype all like a regular Arduino here. And then when you're ready to prototype, you can throw it on the board like I did here, which has that 1K and the LED there connected. Alright, so let's plug this in and hopefully that LED flashes. Okay, so you can see that it does work. So that's good. Otherwise this whole video would have been kind of an embarrassment. So now I do want to test the power switch. So if I turn it off, it does turn off. So that's good. So everything works. The next step would be to test and see if this board accepts a sketch. So if you have your ultimate Arduino programmer board,
which this is an Alpha 1 board, but it does work with Alpha 2 boards. Make sure it's set up for 5 volts, power on. Plug this in, line it up. This isn't keyed or anything, so it's very easy to accidentally plug it in like that. So you don't want to do that. Make sure it's plugged in straight on. And we'll plug this in here, and I'm just going to quickly see if I can program a sketch here. And I'm doing this live without actually testing anything. Okay. That's plugged in. Let me make sure if I got power on, 5 volts. Okay. Okay, so I just plugged in the programmer and loaded the Arduino IDE up to write to digital pin 13, and I went ahead and uploaded a sketch here to change the timing of digital pin 13, and it does take a sketch. So that's very good. So the board is fully tested, not fully tested, but functionally tested so that the Arduino does work. Everything else still needs to be tested, you know, like if you did happen to have one of these pins connected in a not connected perfectly into the socket, then you would discover that when you wire something up to those pins. Okay, so anyway, that is how to build the ultimate Arduino prototype board and test it. So let me know how this goes for you. I'm looking for all feedback, so make sure you look in the description below on how to do that. And I think in the design specification, there's details in there on how to contact me and let me know how the build goes for you. So let me know, and I'm also very curious to see some of the cool projects you guys build with this awesome board. So let me know, and thanks for watching.